All right, on 1-5, this was our quiz, and I told the students specifically not to worry about this or this. It doesn't really make sense in the context of this problem because we're starting on day 1 here. So using the first term makes the most sense. So it's still asking us for the recursive and the explicit. What I tell the students is they need to identify the pattern, the what's going on. So I try to get them to write that somewhere. The what's going on here, on day 1 I've got 4 dots. On day 2 I have 8 dots. On day 3 I have 16 dots. So am I adding 4? No, it doesn't work for all the days. So what I'm doing here is I'm doubling. The what's going on is times 2. So day 4, if you were to put it in, would be 16 times 2 is 32. So I have everything I need right here. I need where do I start and what's going on to solve this. Now this is a little different than the last one. The last one we were adding or subtracting. This one's multiplying, so this is geometric. If we were to graph this, it would actually make a curve that kind of looks like this. Excuse me. So the recursive function works exactly like the last quiz. F of x, the next term in the sequence, equals f of x minus 1. The previous term in the sequence, or the previous day's value. What do I have to do to the previous day to get to the next day? Well, I have to multiply it times 2. Now, a computer has to know where to start that pattern, so we say on day 1, f of 1 equals 4. Those are parentheses, not a circle around that 1. I just didn't do a very good job of it. Okay, now that's the way the computer thinks, the way humans should think about this, and let me be clear on this, this is the more important way to be able to do this. This is just a pattern that looks the same every time. We just change the numbers and the operation perhaps. So this is going to be f of x equals, we pretty much start them all that way. F of x, f of n, whatever. It's just saying, hey, I'm a function and I'm special. So the what's going on is I'm multiplying 2. I don't write the times, I just put the 2. Where the times comes into play is where the x goes. Now I'm multiplying over and over and over again as many times as I want, so that's an exponent. And the number of times that I want to multiply that to goes into that x. Now, I have to make sure that my pattern works with my starting point. So I'm going to plug in the 1 for the day, and I know that that has to equal 4. Well, 2 to the first power equals 2, so that doesn't equal 4. What a lot of students want to do is add 2 here, but it doesn't work. When we're multiplying, we have to stick to all multiplying. So what would I have to multiply this by to make this true? And that answer is 2. 2 to the first power times 2 equals 4, and that makes that true. So that's the adjustment that I have to make here to make that all true. Now, a kid that wants to double check their work will do something like plug in 3 and see if they get 16. Is 2 to the third power times 2 equal to 16? Well, yeah. 2 times 2 times 2 times another 2 does equal 16, because you've got 4 here and 4 there, and you're multiplying those. That checks our work. Oops, sorry. That checks our work. So, anyway, that's 1-5.